So let's look at how to compute the confidence interval for the population mean when the standard deviation is known. And so a lot of these formulas are going to have the same form, so I'm going to emphasize this. So let's first just look at the formula. So this is the formula for the P percentage confidence interval. So P is like 95%, right? 95% confidence interval. And this formula is what we use every time. It says that this confidence interval is equal to X bar plus or minus the margin of error. And X bar is either going to be given, that's the sample mean, right? It's either given, or we're going to be given a sample and we can compute it. So X bar is not really a major concern to us. But what about the margin of error? Well, the margin of error is the product of two things. So the first factor here is what we call the critical value. And it's going to be multiplied by the standard deviation of X bar. Well, we know what the standard deviation of X bar is. So we know that the standard deviation of X bar, is just equal to sigma divided by square root of n. Okay. And this is known by the central limit theorem. And so obviously you're going to be given sigma and n, and you're going to have to find standard deviation of X bar. So it kind of makes sense while we're setting this all up to start to write down these things. So we have X bar here. We have sigma, that's the standard deviation of X. We have n. And from that we're going to compute standard deviation of X bar. Okay. And now we have to figure out what is the critical value. So I'm gonna make a little aside here. So we're going to introduce this notion of alpha. And alpha is going to be, we're going to want to write it as a decimal. It's going to be a probability. And in percentage form, alpha is going to be equal to 1 minus p. It's going to be equal to 1 minus the confidence. So P is going to be the confidence. And let me just write it as 1 minus the confidence. So in other words, if this was a 95% confidence interval, the confidence would be 95%. Okay? And I'm going to write it like this. So I'm going to write this in percentage form first. Okay? So this is 100% minus the confidence. And what I'm going to do is I'm going to find the z-score for the alpha divided by 2 percentile. So the critical value is going to be equal to the z-score for the alpha divided by 2 percentile. In other words, we're going from a percentile to a z-score. So I'm going to enter some things here. Okay, I'm going to enter the confidence. And then I'm going to enter alpha. And then I'm going to enter the critical value. Okay, so these guys are all going to go together. Make that blue. Okay, so these guys are all going to go together. Standard deviation, okay, that's going to be something separate. I'm going to need all of this to get the standard deviation of X bar. And now I can go ahead and work the problem. Okay, so once I know the confidence, I can get alpha, I divide it by 2, I find the z-score for that, that's my critical value, and I plug this into here. And then of course the standard deviation of X bar we already know how to get, and that product just gives us the margin of error. Okay? Let me go ahead and walk you through an example from the book. So This is the formula the book uses, x bar plus or minus the margin of error. You can see this is the z-score for alpha divided by 2, and this is the standard deviation of x bar. Okay. Let's go ahead and look at an example here. So we'll just take one from the book. Let's see. Let me look real quick. I don't recall right off the top of my head what I gave you for homework, so let me just make sure I'm not doing a homework problem just real quick. So we did 1, 2, and 5. Good. Okay. Actually, this is sigma unknown. I need to go backwards. Whoops. I want sigma known. I knew something didn't look right. Yeah, here we go. Okay. So where is it? What page is that? Here we are. Okay. Why is it? Oh, it's because it's starting at 8.2. These are the problems from 8.1. Freaked me out for a minute. Okay. Let's go ahead and look at 8.8. That's kind of a good problem. Let's go ahead and just work that from scratch. Okay. Actually, let me just save this real quick. Okay. So this is problem 8.8 from section 8.1. All right. I'm just going to paste this into the Excel file here. I think this is it. Yep, there we go. Okay. So it says you're working as an assistant to the Dean of Instructional Research at your university. The Dean wants to survey members of the Alumni Association who obtained their baccalaureate degrees 5 years ago to learn what their starting salaries were in their first-time jobs. Okay, so that part makes sense, right? I mean, you're basically you want to call up people that graduated 5 years ago and find out what their starting salaries are. A sample of 100 alumni is to be randomly selected from a list of 2,500 graduates in that class. The dean wants to construct a 95% confidence interval for the population mean. Why is it not possible to use 8.1 on equation 252 for this purpose? Okay. Actually, that's not a good example, but the reason why is because it's not a random sample because you're drawing such a large number of people. Yeah, so this is a bad example. Let me use another one. Okay, let's see, 8.5. Let's see, that's not so bad. But I gave you 8.5, didn't I? Let's see real quick. Yes, I did. But 8.7 builds off of that. So let's look at 8.7. Yeah. Okay. Actually, that's not good either. Let me look at 8.9. Yeah, because I don't want to. This could potentially help you too much with 8.5. Let me just do 8.9. Okay. Whoops. Paste. Okay. This is an interesting problem. I like this problem actually. Actually, I didn't want to do that. I just want to crop it and save it. Okay. All right. So now let's paste this guy. Here we go. Okay, so it says a bottled water distributor wants to estimate the amount of water contained in 1 gallon bottles purchased from a nationally known water bottle company. We're told what the standard deviation is, okay, and then we're told that they collect a random sample of 50 bottles, and they find the sample mean is 0.995 gallons, and want to construct a 95% confidence interval. Okay, so let's look at this. So we know what the standard deviation is, because it says the water bottling company specifications state that the standard deviation of the amount of water is equal to 0.02. So this is not coming from a sample. So here, sigma is definitely known, and that's 0.02. We took a sample size of 50 gallons. So we can figure out, what the standard deviation of x bar is. It's just going to be sigma. That's standard deviation of x divided by the square root of n, which is 50. Okay, and I'm just going to round this off. Okay. So that's my standard deviation. I want to construct a 99% confidence interval. So I'm going to write the confidence as just 1. So this is 100%, but I'm going to write it as 1. Okay, so now, I'm sorry, 0.99, sorry. I'm writing the percentage as a decimal, okay? Because remember that really the confidence is a probability. It's the percentage of times that the method works. So it's really a probability in a sense. It says 99% of the time it's going to work, so I can write it as a decimal. So alpha is just going to be equal to 1 minus the confidence, just like we have here. Okay? And now I'm going to find the critical value. So the critical value is going to be the z-score. So I'm going to have to type norm.inv, right? Because I'm starting off with a probability, which is alpha divided by 2. And remember that the z-score comes from the standard normal. So the mean is always 0, the standard deviation is always 1. And that's my critical value. And I'm going to make it positive, okay? I could either put a negative sign, or I could just take the absolute value of the whole quantity. I'm just going to take the absolute value of the whole quantity. Okay, so this is my critical value right here. So now I'm going to compute the margin of error. So the margin of error is equal to the critical value, which is in D7, times standard deviation of x bar. Which is in D4. Okay. So I'm going to go ahead and do that. Just take that product. So D4 times critical. That's my margin of error. So now I'm going to compute the 99% confidence interval. Okay, I know what it is. It's x bar plus or minus the margin of error. So I'm going to compute the lower endpoint. I'm going to compute the lower confidence interval endpoint. So this is going to be equal to x bar minus the margin of error. Okay, so I just do that. I didn't enter the x bar, so let me just enter it again. So they found that the sample mean was 0.995. Okay. So now I'm going to go ahead and take x bar minus that, minus my margin of error, and the upper endpoint, upper confidence interval endpoint, whoops, is just equal to x bar plus the margin of error. And notice I can just cut and paste this and change the plus to a negative. Okay. And so I know that the 99% confidence interval for mu is equal to, and it's going to be from 0.98 9877 to, I'll round this off to 2 decimal points, 1.0023. Okay, so that's part A right there. That's my final answer, if you will. All right. Now let's see. So they ask an interesting question. They say, on the basis of these results, do you think the distributor has the right to complain to the water bottling company? No, because they say that it's going to be 1 gallon, and 1 gallon's in here. So the true mean could be 1 gallon based on this sample. Okay. Must you assume that the population amount of water per bottle is normally distributed? So in other words, did we have to assume that X is normally distributed? No, because the central limit theorem kicked in, right? I had more than 30 bottles, so whenever I know the standard deviation and the sample size is greater than 30, X bar is automatically normally distributed. So C is no. If I want to construct a 95% confidence interval, well, think about it. If we want to be less confident that we contain the mean, it's going to be smaller. The interval is going to be smaller. Notice I can just change this one value, and everything else will change. If you watch this and this, well, if you watch this and this, they'll all change. Okay. I'm going to go back to the original. But you could construct a 95 just by changing this one number because everything's indexed. Okay, I hope that helps you with that. I'm going to finish up confidence interval with sigma not known next.